All right, everybody. Can you please give it up for Chris Koehnecke, who will be giving a talk on minimum viable security.
All right, good afternoon, everybody. What an awesome day here in Knoxville. I'm super excited to be here. I mean, all these different talks, all the different tracks. We all love our technical tracks, but there's a lot of career-oriented tracks. There's soft skills, building up your resume. Cybersecurity is such a broad field, such a growing field. It's great to see all these talks, and I'm super excited to talk today about a topic that's really important for me. It's simple and straightforward practices for securing cloud applications. And the way I like to start this talk is a bit of an analogy. Just curious, how many Beatles fans in the audience out here do we have? Not too many. Okay. How many people know who the Beatles are? Much better. Okay. And if you know who the Beatles are, maybe you saw this recently. A couple years ago, Peter Jackson released this movie, Get Back. It was a documentary about the Beatles. It's more for a Beatles nerd like I am, quite frankly. But we all love Peter Jackson for Lord of the Rings and all the awesome movies that he's done. And what was really cool about the movie for me was that you got this really up close and personal view of how the Beatles write songs. And if you know their songs, the final product can be very complex. All these orchestral pieces, these different layers, they're works of art. But how they started was in simple ideas, simple musical ideas, and they built on that. So starting small and iterating is an important step in really anything that you do. But cybersecurity, it's important to start with a really good baseline foundational understanding and build from there. So that's one of the big things that I took from the Get Back documentary. A bit of background about me. My last name is difficult to spell and say. You can just call me Chris. So I'm with an Israeli cybersecurity startup called JIT. So JIT is an acronym for just in time. I'll talk a little bit about that. But I did want to share just a quick story about my history in cybersecurity. I was with KPMG and did Big Four consulting in cybersecurity for 15 years. So I started as an associate level near the beginning of my career, worked my way up to partner, and I led our cloud security compliance practice. Basically what that meant was that for any cloud service provider looking to get a certification, whether it was something like SOC 2 or ISO, or also looking at some of the more complex certifications like FedRAMP, and that was really our specialty, we'd take these products and these teams through these compliance processes. I love the consulting gig. It's a lot of fun for those consultants out there. You get a lot of different varied experience. At the same time, there was a common theme that I found, is that we'd bring in these security practices and processes, and it would really stifle developer velocity. Like, the developers, in particular with the cloud companies, they're very inventive, all these new solutions that we're creating all the time. And then all of a sudden now you've got the security process that doesn't make sense to a developer. They have to start following that process. So oftentimes we'd achieve the goal from a compliance standpoint or the outcome, but the business would be hurt and the developers would quite frankly, would leave the company. So I got the opportunity to join JIT and really looking to change the game, empower developers with security, and support developers with getting vulnerabilities and issues while they're developing, and can fix things while they're developing and make it part of their regular routine, just like a bug, basically. That's what we're all about. So again, we're a startup called, it's JIT for just in time as an acronym, based out of Israel. I'm actually the first US employee, so we're only 40 people, 38 developers in Tel Aviv, and then myself. And just a couple other things I could share is that I love, I have your developer, tech, and security, all the different pieces around technology. Love being a part of that, also with compliance. And clearly I'm a big music fan. Talk about the Beatles here a little bit. We're talking about security. All right, so back a bit about the Beatles, and those of you that have seen the documentary, or if you even see Peter Jackson's movies, they get into the details there. And you got to see like a really up close and personal view about how the Beatles wrote songs, how they interacted with each other. You get to see some of the drama too. You got to see, John and Paul fighting. You got to see, with their wives in the room. No one's getting along. People quit the band. It's, some of the drama there is kind of fun to watch. But at the same time, you got to see again the origin of these songs, and even the song like "Get Back," if you're familiar with it. Paul just starts playing a very simple riff. It's not complicated. Right? Just starts playing it, something that just came to him as inspiration. Very simple, but then you get to see the other band members pick up on that, add their different pieces to it, and then all of a sudden you've got a song out of nowhere, right? But again, that starting small and iterating was a huge part of the Beatles' success. And you got to see an up close and personal view of that in the Get Back documentary. And here's just a few examples again of how complex the music is. Not expecting you to read sheet music here, but there's a lot that are in these different songs, all these different layers. But if you break it down, again, it's like 3 chords and the truth, right? I mean, it really isn't that complicated from a foundational level, and then you build from there. So again, just to start small and iterating is always a good practice, as well as cybersecurity. All right, so let's take that kind of starting small and iterating and translate that over to cloud environments and talk about some of the baseline controls that really any cloud environment should have in place. If you look at this, first step, you want to protect your perimeter, right? And how do you look at your perimeter? There's a few things here, and again, we're focusing on cloud environments. I'm curious, just as a show of hands, how many people have cloud in your day-to-day activities? Pretty much everybody, right? AWS, GCP, Azure. What about in terms of developing software, like using GitHub, GitLab, any kind of source code management systems like that? Pretty much everybody. Not everybody, surprisingly. But if you look at the kind of the modern tech stack, if you will, cloud cloud technology along with the appropriate source code management systems. Looking at your perimeter could be relatively straightforward, right? You've got those public resources, your website, your public IPs you want to protect. You've got your CI/CD pipeline, whether that's like GitHub Actions or using Jenkins to roll in updates and changes to your application. Of course, you've got your user access, and there was a talk earlier, and I agree with it that role-based access and identity is the new perimeter. Super important to lock down user access. And then third parties, of course. I mean, now it's using third parties and integrating with your cloud environment every single day and making changes. So, it helps again to look at just simple ways to have buckets of what you want to focus on and looking at the perimeter from that perspective. So then we think about what are the controls that we want to implement for each one of those pieces of your environment and your perimeter. First off, for CI/CD, it's fantastic. We can make updates to our cloud application, multiple updates per day, constantly making changes, improving user experience, new feature, new functionality. We want to make sure that CI/CD, application service has least privilege. You want to minimize the privilege. Looking at those public resources, you want to make sure that you're avoiding anything like cloud misconfigurations. You can run pen testing on your external applications, web and API-based scanning from an external perspective. Looking at those third parties, you want to make sure that you've got MFA in place for any of the access to your third-party applications, and then you have the appropriate scope in terms of connectivity to your resources. So evaluating those third-party applications appropriately. And then looking down at your users, of course, again, MFA is super important, and then you've got appropriate role-based access and least privilege. So again, a simple way to look at your cloud environments and think about those core controls you want to make sure that you get right. And again, back to the Beatles, if you look at the simplicity of how they started their songs, it was this a simple thing like Paul's on the piano just playing a simple melody or a simple line, John on the acoustic guitar coming up with something. Again, that's how they would start the process and build from there. All right, so we talked about the perimeter. Now, what about inside your application? And what are some of the key things that we want to make sure we protect? Again, starting small and iterating. Of course, we want to protect our traffic, internal traffic that's being transmitted processed and stored inside of our environments. You want to protect any of those secrets out there, your passwords, your keys, your tokens. That's important. Any access to your microservices, you want to make sure you've got appropriate role-based access and permissions to your services. You want to make sure you have an incident investigation process, right? Just having a basic way to be able to respond to any potential issue, event of interest. You want to protect your software libraries. You want to track your software libraries. Of course, there's been a lot of talk around supply chain. So making sure those are appropriately tracked and managed and protected. And then also your backups, right? Your disaster recovery, being able to restore back from an issue, from an outage. That's another important thing. So again, simple things here, but you want to make sure you prioritize these as step one as your baseline of your security program. So what are the controls that you want to put in place for those internal pieces of your application? So for your traffic, clearly encryption is a key control to make sure that you're properly encrypting and protecting that data. You want to have some types of a secret manager in place that's protecting those tokens and hiding those tokens appropriately. Again, least privileged in access to your services, making sure you evaluate and look at that, the various privileges and have RBAC in place, role-based access control in place. For your incident investigation, you got to have the appropriate logs, right? So making sure you have appropriate logging, set up, enabled in your environment, internal in your cloud environment. For your software libraries, you're running the dependency check, so you're aware of any vulnerabilities that are in those software libraries, and what's the criticality of those, and then you're running appropriate backup. So again, a simple way to look at your environment and think, am I doing all of these things? Is baseline security, is a minimum viable security approach to help us build our security program, and then we can build from there. All right, so here's just a quick graph or chart that shows specifically some of the controls and how these fit into your perimeter as well as internally in your environment. Kind of starting from left to right and looking at your source code management systems. You've got GitHub. You're running the appropriate dependency check against those software libraries. And then for GitHub Actions, then you're going to have the appropriate privileges, whether it's GitHub Actions, Jenkins, or another CI/CD platform. You have the appropriate privileges set up. You want to make sure your public access is properly locked down. You're running things like penetration testing from an external perspective, web application testing, web application security testing, API scanning. All those things are happening from an external perspective. And then looking at your third-party services, you've got your APIs, right? So which APIs are you using for your third parties, setting up those APIs and the scope of those services so the access permissions are set correctly and your APIs are set correctly. And then of course for your users, again, the MFA is in place for both administrators and for any of your regular users and your customers. So again, just a baseline security is something for you to go back and look at your environments. Am I doing these baseline security things appropriately? Am I missing some things? Because this is the most important stuff that you want to focus on. All right, so hopefully this helped us to kind of paint the picture of what does a minimum viable security approach look like? And what are the minimum controls that we should focus on? But now, looking at what are the types of vulnerabilities and risk and issues that we could potentially detect around these different areas from a minimum viable security perspective, and how we utilize those tools. All right, so one of the things we put together at JIT is one of the things that we're doing all the time is we're evaluating tools. And I think that's another important piece is that your tools in your environment, it's not always going to stay static. You might make a technology change, you might have a replatforming, there could be a need for kind of a tool reevaluation process. Tools get better and worse out there as well, right? So it's important that you have a regular process to evaluate your security tools to make sure that they're the best fit for your environment. And you can make adjustments over time as you need to once you have that process. Again, here's a simple process that we've utilized to select which tools that we like to use at JIT, right? First off, we'll look at the various risks associated with our environment. We want to avoid things like SQL injection for an attacker to get level of access into our environment. How do we potentially avoid that risk or mitigate that risk? We want to validate the data input, so we, from a security requirements standpoint, and then we'll pick the appropriate tool. So, for example, we like OWASP ZAP to be able to help from an external perspective, and we're running external scans, web application scans and API scanning to check for this risk, and then we run those tests, tests and scans on a regular basis. So here, now we're going to walk through, looking at some of the different security tools based off, again, that minimum viable approach, and what tools that we recommend that we utilize and why. So again, back to looking at your code, you want to make sure you don't have vulnerabilities in your code. So using tools like static code analysis scanners, that's an important step. There's a lot of static code analysis tools out there. One thing I'll say that at JIT that we did is, we evaluated open source tools, we evaluated proprietary tools, tools that cost money, and we found that in a lot of cases the open source tools actually perform just as well, if not better, than some of those expensive tools out there. So again, that's an important step of your kind of tool selection process as you go through. But looking at things like static code analysis, we found a tool, SEMGrep, out there. Again, open source, free, anybody can use it. But we found that SEMGrep found more, or I should say fewer false positives, more exploitable vulnerabilities, even in comparison to some more expensive tools out there like a Sneak, for example. So we really like SEMGrep, and there's other reasons why we like it too. 2,000 rules, there's a ton of rules out there you can utilize for SEMGrep. Supports many different languages across the board. It can run everywhere, so as a developer, it's easy to use. Super fast to run static code analysis with SEMGrep. It's extensible, different output formats that you can utilize, and it's easy to configure. So this evaluation process, we said, hey, SEMGrep meets the needs for us. It's a free tool out there. Anybody can use it. It really helped us to find more exploitable vulnerabilities in our code that we could fix. Also around our code, we want to make sure that, again, back to the secrets and secrets manager, is that making sure that we don't have hard-coded secrets in our code. It happens all the time, right? It's one of the most common exploits out there is the inadvertent or malicious exposure of your secrets. So you want to have the appropriate scanner in place that's going to detect those things, right? Your tokens, your AWS keys. And again, evaluate different tools out there. Back to open source, Gitleaks, we found was a fantastic tool that found the most real secrets out there, the fewest false positives in our environment. So again, it supports many different types of secrets out there, API keys, AWS credentials. It supports in your Git history, so not just in your current code. Sometimes you fix something, but you've got old secrets in your Git history. Gitleaks will find that. You can go back and fix it. Super customizable, again, to ignore known false positives, and best-in-class accuracy, right? So again, an open source tool, free for anybody to use, but just as good, if not better, than a lot of those tools out there that cost a lot of money. Talking a bit about, again, software libraries and dependency checking, again, looking at your code, but we want to track those third-party libraries and understand what vulnerabilities are potentially present in our software libraries. So we want to use a scanner to be able to detect those vulnerable libraries. And this one's a new one. Again, I talked about changing tools all the time, and all the time, but you got to your threat landscape. You want to have that process in place to evaluate if your tool is the right fit. And we recently made a change. We're pretty excited about this one. Again, open source tool, but it's by Google. So Google's been managing this OSV open source vulnerability database for some time. They recently released, I think it was in January of this year, so early this year, a scanner that runs on top of the OSV database. And we love it, for those reasons. Again, it's free, but managed by Google. They're updating that OSV database all the time. So we have a lot of confidence that the latest software libraries out there are being detected, or vulnerabilities with those libraries are being detected and being notified through the scanner. Supports many different languages, so you're covered from a language perspective. It can run anywhere, easy to use as a developer to be able to run these scans. You can again scan specific SBOM, and then you've got software bill of materials, and then multiple options in running the OSV scanner as well. Now a bit about the infrastructure and infrastructure misconfiguration. This again is a super important control. Again, going back to that minimum viable security approach, is that you want to be able to, and again, I don't know why this is the case with cloud providers. We love cloud, makes our life a lot easier in a lot of ways. But a lot of those default settings out there, why S3 buckets are publicly accessible, why some of the different default settings are making us more vulnerable. It's a challenge. Maybe the cloud providers like it that way because they get more professional services. We want to detect those infrastructure misconfigurations as they happen. So we want to run a scan across our cloud environment and detect those. Again, we looked at an evaluation of different tools, and we found another open source tool that does a fantastic job of finding potential infrastructure misconfigurations in your environment. It's a tool called KICS. And if you some of the facts here about KICS, it's constantly being updated, right? So there's 2,000 queries out there that it's checking for. So that, it's checking for a lot of different potential misconfigurations out there, supporting many different frameworks. It's being updated all the time. So there's this nightly build, and it has all these different built-in remediation recipes. So not just finding some of the vulnerabilities, but helping you to fix those as well. So we like KICS a lot to help for that minimum viable approach from an infrastructure misconfiguration perspective. All right, now a bit, pen testing. I know, pen testing can be viewed, different ways. Of course, there's kind of the more classic. You hire a pen tester. They're going to come in and perform different types of tests. The best pen testers utilize different manual process to be able to detect vulnerabilities across the board. But there's a lot of pen testers are using automated tools as part of their first step. And you could do a lot of that as well from a minimum viable security approach to detect vulnerabilities. So, looking at pen testing, you want to simulate those attacks on your front end, your publicly accessible environments. You want to utilize appropriate, web application scanners to be able to detect those vulnerabilities and fix those. And for again, looking at open source. There's some good tools out there. Burp Suite's a great tool. We like Zap a lot. Zap's been around for quite some time. I'm sure many of you have heard of Zap. It's supported by OWASP. Helps detect those OWASP top 10 risks. It's got a ton of rules out there. It's been around for a long time. It's supported by Simon Bennett. If you know Simon, he's been leading the Zap project for a very long time. So there's a lot of consistency there. You could run Zap pretty much anywhere. And it's got all these different extensions. So there's all these different kind of tests you can do with Zap. So all the different kind of flexibility with Zap, we really like that. And again, it's free for anybody to use. So that's a really nice feature. Up next, looking at your container images in your pipeline. When you're building your container images, you want to make sure there's no vulnerabilities in those base images. So you want to run scan, against your Docker file images and be able to detect vulnerabilities in the environment. So again, we looked at different open source tools, and we also looked at some proprietary tools. We found that Trivy, again, another open source tool, does a fantastic job of finding vulnerabilities, fewer false positives and more exploitable vulnerabilities. It supports running a lot of different types of files, so container images, file systems. Trivy can do a lot. It can also generate an SBOM, so it can do other things than just scan those base images. Super fast to set up. It could run pretty much anywhere. So we love that flexibility about Trivy. And then from a multi-factor authentication perspective, looking at our third parties, We want to make sure we have MFA set up, and again, looking at kind of a simplistic tech stack, make sure we have MFA enabled on, for GitHub, AWS, and Google, and enabling MFA. We've actually put some custom tools in place to be able to check to make sure that we've got MFA on all our third parties. So it's no open source tool that we're utilizing today, but we've built some custom scripts in house to be able to check and make sure we've got MFA turned on for all our third party access. All right, well, I hope that was helpful to kind of go through some of the tools, right? And I think maybe for a lot of you, the minimum viable security approach, you're like, yeah, I get it, and hopefully you're doing that, but maybe just a quick refresher on things, maybe you potentially are missing something. But then I think what's fantastic about this is all these open source tools that are free for anybody to use are out there for you to be able to detect vulnerabilities associated with that minimum viable security approach. So you can detect these vulnerabilities, you can fix them in your environment. You can have some comfort that you've got those baseline controls in place, without spending a ton of money on all these proprietary tools. Now, I kind of gave the answers to the test in terms of tools that we picked that we're utilizing. But again, we went through an evaluation process, and our tech stack is we have AWS, we utilize GitHub, we have a set list of third parties that we utilize. So there was a mentioned earlier talk that everybody's kind of a special snowflake a little bit. So, which is true. The tools we picked maybe not the best tools for your environment. So how do you go through and pick which tools that you want to utilize, to help you kind of build your toolkit and change over time as well? So there's a few things that we look at to help pick the tools. One is that result quality, and I touched on this a lot. Is that one of the great things about a lot of these open source tools, and we did a lot of analysis, and the research part of our company, we did analysis to make sure that we're reducing those or minimizing the false positives, and having real exploitable vulnerabilities are being detected. But that's of course probably the most important thing on a tool, because if you're chasing false positives, never fun for anybody. The developer experience. That's super important too. Again, our mission is to empower developers with security. That developer experience of utilizing the tools, it's got to be simple, right? You got to be able to turn it on, set it up, run the scan. If it's too complicated to be able to configure and utilize, your developers aren't going to use it, right? Plain and simple, and they shouldn't use it, quite frankly. The maturity of the open source tool, and this is really more of an open source thing, but you might have some concerns to say, hey, is that open source tool, is it going to be there for the long run? Maturity is an important point there to kind of evaluate if you're going to go the open source tool route, and then customizability of the tool, right? Can we, based off our environment, can we have set up the tool the way we need to avoid those false positives and find those real vulnerabilities that we can act on in our environment and reduce risk across the board. So here's a double click on those different criteria, and I think this can help as you think about your tool selection. Have I picked the right tools, right? Or did maybe a previous regime in your company pick the tools, or someone else that didn't know a lot about the environment pick the tools? Maybe you had a good relationship with a vendor, or there could be a lot of reasons why a tool was selected. But kind of going back and checking, this could be helpful to say, hey, have we picked the right tools the right way? Looking at that result quality, again, the false positives and false negatives, running the tools on your code, right? And then vulnerable repos is a second option. That's an important test there, right? And it's running some of those tests yourself, and then comparing those results between tools. So I get it. Not everybody has a research arm as part of your as part of your teams, but if you could do some simple checks, right, to say, hey, this tool works better, or you could look at some of the leading practice thought leadership out there in terms of tools that are the right fit. But look at that result quality, right? Are we getting the best result? And if we're getting too many false positives, is it time for us to think about changing the tools that we're using? From a developer experience perspective, again, I talked about how important this is. If you want to empower your developers with security, they have to be able to use the tools, right? So they run everywhere the developers work, fast, easy to use, The results are easy to understand, human readable or machine consumable, and run the tool yourself, right? Make sure your developers like the tool, they like the look and feel, get their buy-in, right? I mean, that's an important piece. Don't just give them a tool. It'd be like back in my KPMG days, you'd be like, here's the best tool, just go use it. And the developers hate it, right? It's never a good situation. So make sure the developers run the tool themselves and they're comfortable with it. And then that maturity piece, and again, I'm focusing more on the open source tools, but it's still relevant for some of the proprietary and paid tools. Is that tool popular, right? So from an open source perspective, you can go look on GitHub, see the stars, the forks, the watchers. It's like the restaurant reviews. Before you grab dinner tonight, you're gonna go look at the Google reviews. Especially for an out-of-towner like me, I live in Dallas. I'm like, where do I go in Knoxville? I'm gonna look at the restaurant reviews, and it's not how I'm gonna pick the restaurant. I'll ask some of you too where I should go. But it's an important input, right? So that kind of the general public's view on that tool can help you say, hey, is this tool accepted out there? Is it utilized? Is the tool owned and actively contributed to? Like, for example, I talked about KICS earlier, right? And I said, hey, there's this nightly builds and all these 2,000 checks. That gave us comfort that, hey, it's being updated all the time, right? The tool is owned. It's an active tool. It's not, out there, orphaned or not being actively updated. You want to be, in particular with open source tools, pay close attention to that. And then the other thing too, with open source tools, you got to be careful. Is it, okay, do I get just a small piece of this tool and then I have to pay for the rest of what I really want? And is that going to change over time from a licensing perspective? So that's an important point there too. And that's something that you should be aware of. So it's good to sometimes have a backup tool, 2 or 3, right, to be able to make that decision. And then the customizability piece, right? I talk about the reusability paradox, right? The more generalizable something is, the less utility it has, right? But you still just want to make sure that you can fine-tune that tool to account for how your code practices, your languages, the processes that you're utilizing. That tool needs to be customizable enough to meet your developers' needs. All right, so I hope this is all kind of coming together for everybody, talking about baseline security practices, that minimum viable security approach. Hopefully that was a lot of review for most of you, but if you're missing anything, hopefully say, I'll go back and check that. And then some of the tools that you can utilize to be able to, again, and open source tools and free tools that you can utilize in the process to be able to pick those tools to detect vulnerabilities that your developers can run while you're developing. Is an important step. And here's just a quick view of that minimum viable security plan, right? So, within your code, your code vulnerabilities, secrets, appropriate logging, those vulnerable libraries out there, your infrastructure, cloud misconfigurations, least privileged access, your runtime, again, that pen testing, API security, web application scans, your pipeline, vulnerable containers, least privileged access. Your data, appropriate data encryption, secret storage, third parties, multi-factor authentication, secured access in terms of scoping those third parties. Your people, you've got password manager in place, and then your operations that you've got appropriate auditing, logging, and backups. Again, just some baseline things. It's a good practice, for any progressive. Any progressive organization out there to make sure that you have in place from a security perspective. You can maintain developer velocity. Your developers can own security, and ultimately it can help your product grow while you're still embedding security as part of your process. So I do want to share a bit about our product at JIT, because one of the challenges that we had is we said, okay, this is great. I understand my minimum viable security approach, and I can build from there. I'm going to pick certain tools to be able to, and have my developers run those tools as part of their development process to take those vulnerabilities, and they can fix those vulnerabilities. But the challenge that you have still is you're maintaining those tools. You have to run those scans on a regular basis. You may have to create something in-house to be able to manage all of that in terms of from a security perspective. That's what we build at JIT. right, is an orchestration platform to do all that for you. Automate all the scans, run all the scans when you need to. And again, we're an acronym for just in time, because we want to detect those vulnerabilities. Is your developing? Developers can see those vulnerabilities, no context switching. That's the other thing. You don't want to have to log into some other tool, get the vulnerability, then go back to developing. Once you've done that, how much time have you wasted? And developers hate wasting time for good reason. So share those vulnerabilities with them in their native environments, in GitHub, where they're actually developing, in GitHub, in GitLab, in Bitbucket, where they're actually developing. Make those fixes, while you're developing. That's the way to do it. So that's what we have at JIT. But what's important to note is that we haven't necessarily championed any single tool, right? I went through the process of the tools that we like, the evaluation that we went through with the tools that we picked. We like them for our environment. But again, you may like different tools. And I'd encourage you to look at that with your vendors, is that do you have the right tools in place? Because we're an open orchestration platform, so you can bring any tool into our platform and you can orchestrate that. It can be open source, it could be a paid tool, for example. But I think that's an important point is, again, your tools may change over time. And as they do, you want to be able to make those changes quickly, and having a platform that's extensible where you can make those changes is a really important part of a security program, and helps you to, again, maintain that developer velocity and detect risk and vulnerabilities at the same time, which is what it's all about. All right, well, that brings us to the end. I hope everybody enjoyed the talk. I'd love to take some questions. We got some time here too before the next one, so I'd love to take some questions. But again, back to the Peter Jackson thing. He's got the next steps on his journey. I heard he's got like another Beatles-esque documentary. He found some other lost footage he's going to pull together, which is kind of cool. We're doing the same thing, right? We're evaluating different tools all the time and looking to add different tools and different capabilities from a security perspective. Starting with that minimum viable security approach, but growing all the time and getting better and better and stronger and stronger. So thanks everybody for your time. I brought some. I mentioned we're a startup from Israel. I brought some JIT swag, which I'd love to share with you just a little bit. But you don't have to ask a question to get it. You're welcome to grab something. But if there's any questions out there, love to take your questions now.
Any questions for Chris?
Yeah.
Well, what distinction, if any, do you make between security testing software applications and software services, APIs, and microservices?
Yeah, I think the key there is that, and it's a good question. And the question was around, the way I look at it is securing your code and then some of the runtime checks that you're running, right? So you've got to do both, right? I mean, obviously, we want to shift left. We want our developers to fix vulnerabilities as they're developing. That's going to help us be more secure. But that doesn't mean there's still not going to be vulnerabilities while your application is running and runtime. So you've got to do both, right? So the way we handle that is we're running all of the like the code scanning checks constantly, right? So for every commit, every pull request, we're running those security scans, detecting vulnerabilities, and sharing those results with the developer so they can fix those vulnerabilities then. Then we'll run all of like the runtime checks. Like I showed Zap, like we'll run Zap daily, right? Run Zap every single day, or if there's a major change, we want to run it more than daily because daily is pretty good, right? We'll run it on a scheduled basis and detect those vulnerabilities in our environment from a runtime perspective. Sure.
How do you feel about IAST?
I think IAST is, actually, I just had a conversation about that recently. I think it's a good practice. One thing we haven't figured out is kind of how to orchestrate an IAST tool in our kind of toolkit, right? So it's kind of a separate thing to be able to. But I think it's an interesting thing. We're evaluating it. It's something that we're looking at too. Yep. Great. Any other questions out there from the group? Well, if not, again, thanks everybody for your time. This has been a blast to be here in Knoxville. Great group of people. We got a few more talks, so looking forward to talking with all you later on.